Calculus students, I want you to see something. This is where math now all of a sudden transcends the classroom, and this is so cool. Let me show you what we're talking about here. I found this graph from a source called medium.com, which means anyone can make it. So just take it for what it's worth. I'm not here for a political debate or a rant about what's right and where you got your numbers and who's reporting. I'm just simply going to look at the math and just talk about this as just a person and how calculus is now so much more than just a book and doing assignments. So if I look at this and I'm thinking, how do I take calculus in this? Well, the first neat idea is I could just start from zero, right? And I can go to 25. And for instance, if I want to grab Italy, just by example, we totally can see area under the curve, right? And I can now get why I would actually use all these different approximations. And there's my integral right there. Next really cool part, watch this. I'm going to zoom this in. If I go straight up from my 25, right, and then I go straight down to here, right, watch all of a sudden all of what we've learned come into place. There's that. There's that. Ladies and gentlemen in the world, for all calculus students out there, that's your trapezoidal approximation right there. So you'd be making trapezoidal approximations for each and every one of these. And you get the idea of we don't have a function. There's no function that we can make that could model Italy right now, right? Because it just keeps changing. And I can't make just a nice, simple logistic equation. I can't make a polynomial. This looks very logarithmic, right? Because it just bounces. So this is why we in the world have learned why you can make a trapezoidal approximation. All right. Oops, sorry, I'll finish that up. It is so neat to see what we are learning with the context around us. This is just for the people out there that want to see this. I was just fascinated by this graph. I mean, it's very sad, and my heart goes out to all these different places and everyone who's battling this together. But I'm letting the math just speak now here for a second. I had the privilege to travel to Spain, so my heart is very dear to Spain. What a lovely, lovely country, lovely people. Watch how I could use calculus with this. I love it. And I got some good news for the people of Spain. I know you have had no good news, but here's one good news. You're concave down. And I'm so happy for that because here's what it means mathematically. Everyone, I'm going to talk about our second derivative, right? And this is so neat because watch this. If I look at Spain, which I'm going to use my highlighter and highlight Spain with you and follow this curve, it goes like this. And I'm so happy because this is concave down. So my calculus students around the world, watch. There's my tangent line. Oh, sorry. You should try to be real precise here. My tangent line would look like that guy. Then I'm going to go here. The tangent line is there. Then I'm here. The tangent line is there. And my pen can't really do it the best. I really would love it to. The neat part, you guys, is watch this. The tangent line was here. Now it's here. Now it's here. And now it's here. So I want you to see the pattern of the tangent lines, right? If I can take this and show you, look at the evolution of my tangent lines. If I can put it somewhere white to show you, they're decreasing. That's the whole idea, is the tangent line is like this, and it's slowly coming down. And guys, that's our second derivative. Look how neat this is. And now I'm analyzing all the different countries of the world. And I'm like, okay, this is so great. Japan, I see that you're concave down, so I'm going to follow Japan and look at that. I'm looking at the concavity of this. South Korea, you're still, but so I saw this here, and then it went up. And now if I'm following that curve, that tangent line right there, that tangent line. So watch that tangent, and all of a sudden, then okay, good. It started to go that. And look at that. That's almost going to flatten out right there, right? Now, you better take your scale into play when you're doing this. So don't let me speak or teach wrong on this, right? You better be wary of this scale, and you better be wary of this scale. And basically, I hope you can see that I'm finding this from a good source, hopefully, right? Okay. So look at the math come to life, calculus students. It's our trapezoidal approximations. It's our concavity, right? Now comes the idea of an inflection point, right? What's the inflection point? This is so neat. This is why I'm a little concerned with the USA. Watch this. If you were like this, if I was following the USA, right, this thing would kind of come like that and go like that, right? So that tangent line would be like that, and then I need that to change, right? So watch as I zoom in here, okay? Let me try to show you this real quick, guys, right? I'm coming like this, it's like this, it's coming up, and then it changed right there. Kel kids, that's inflection when all of a sudden that tangent line goes like this. So it's starting to grow, but then it stops growing and actually starts to flatten out back again, right? That is so neat because that is when d dx, right? D squared, dx squared, right? D dx squared, that's when that thing equals zero. That's what we call an inflection point, is when the concavity changes, right? So I'm looking at my home country and I'm a little concerned because this is great. This is concave down, but then look what happened. It went back to concave up, and now it's back to concave down, and now it's starting to go back to concave up. This is the scarier part about all this, guys, right? This curve is starting to go like that. Look at the curve of Italy and Iran and China and Spain. Their curve is starting to do that. So I think it's a little bit worrisome now if you can use just math and not talk about politics. I'm just talking about the concavity of this, right? It is so neat to see math come alive for you. I've been reading these graphs. I'm fascinated with it, about basically just looking at these curves and what's happening, and just, are they concave up or concave down? I mean, Spain has a great example right there. I'm looking at that change, right? This thing looked concave down, and then all of a sudden, you want to see a great idea of an inflection point? Watch this. This curve is coming like this, and then all of a sudden, that curve went like that. That right there, guys, is what we call inflection. So it has so much more meaning now than just an arithmetics, more than a piece of paper. So this is what's so fun when you get to study applied math. You start to talk about what's happening mathematically and then what it means to the world. So I saw this and just wanted to make a quick video for all the calculus kids out there, and whether or not you see it or not. But for my class, I thought this was absolutely spectacular, guys. So just wanted to share that with you. I hope you're having a great Wednesday.